Here's some homework solutions for section 8.1. A few common questions. 41 comes up quite a bit. The pattern here is kind of tricky. There's a couple common things that you really want to be looking for on a regular basis. This is probably one of them. The best recommendation I can give you is to maybe just see what are you adding or multiplying to go from one term to the next. And there is a pattern to how you're adding, and you're adding an increasing pattern of odd numbers each time. Now hopefully that rings a bell from something we did really early in the year that had to do with parabolas and opening patterns. And that's the pattern between perfect squares. You add the next odd number up. And we explored why that's the case, but that is the case. And hopefully that if you start thinking about squares, you start looking at these and realizing each one of these is just one off from a perfect square number. So let me just put that underneath. 4, 9, 16, 25. Those are all your perfect squares, and these are all one less than those. So probably the easiest way to do this is realizing you've got some perfect squares going on. And n does need to start with 1. So I would just kind of jump in here, and if we need to adjust and say like n plus 1, n minus 1 later, it's not too hard to do. Let's see what happens if we start with n squared minus 1. Since again, these are perfect squares, and each one of the actual numbers in the actual pattern are one away from those. So if you put in 1 for n, and you square it, you get 1, minus 1 is 0. Put in 2 for n, you get 4, minus 1 is 3. So that seems to be checking out, and n squared minus 1 is going to be the pattern you want to use. So be looking for perfect squares. They do come up quite a bit with these patterns. 49 is another really common pattern that you're going to see. The top is pretty easy. It's always 1. So my final answer is 1 over something. Now on the bottom, let's check out what's happening each time. So I'm adding 1, and then I'm adding 4, and then I'm adding 18. I'm not really seeing a definite pattern there, and I'm not going to say there's not a pattern. I'm sure that you could come up with something. But let's try multiplication. So 1 times 2 is 2, 2 times 3 is 6, 6 times 4 is 24. That may not be really familiar, but that's your factorials. And hopefully at some point you have explored factorials. For example, 5 factorial is 5 times 4 times 3 times 2 times 1. So when you start seeing an increasing pattern of multiplying by the next number in a series or in a sequence, that's going to be a factorial. That's what these are. That's 1 factorial, 2 factorial, 3 factorial. So that's what your pattern's going to end up being. Put in 2 here, it's 2 factorial. Put in 3, 3 factorial. And 1 over n factorial, that is your result. 71 is another factorial that needs to be worked out. And this is later going to become what's called your combination formula. And again, maybe you've played with that in Algebra 2. It's one of those topics that you're supposed to make it to, but I don't know what happened with all the chaos last year. So anyway, you will recognize that later. So we're doing one of those deals where we play around with the math because we can. But then later on, you're like, oh, that's what that was. And it was actually a formula. So 12 factorial, again, that's everything from 12 to 11, counting all the way down until you get to 1. Same thing with 8 and 4. So here it is expanded out. Now this is a lot of writing, and you really don't have to do this every time, but it's kind of fun to scratch things out. So I'm going to start with this. Everything from 8 down to 1 is the same on the top and the bottom. So I'm just going to scratch all those out. Something you'll get pretty good at right away, I believe, is seeing that, all right, wait a minute, everything from 8 down goes away. So let's say 12, 11, 10, 9. And then we can deal with the 4 factorial later on. So that's kind of where I always start these. And I don't ever write all this stuff I just scratched out because I don't really need to. And now let's see what else can go away. So 4 times 3 is 12. And I've got 2 down there. 10 is the only odd number I have left. So if I divide 10 by 2, I get 5. And the 1 I don't really care about because it's not going to change anything. So let's see what we have now. We've got 11 times 5 times 9, and that is 495 when you multiply them. 73 is a pattern you're gonna see from time to time, so we do need to get used to it. So it's n plus 1 factorial over n factorial. Now again, the way factorials work is you start with the number given and multiply by everything counting down to 1 underneath it. So 5 times 4 times 3 times 2, stop at 1. So n plus 1 is going to get multiplied by 1 less than it. So n plus 1 minus 1 more would be n. So that's the next term. And if I've got n, and I subtract 1 from it, I really don't probably need to do any work there, it's n minus 1. If you subtract 1 from that, it's n minus 2, and so on. So that's the pattern. So again, just subtract 1 from whatever you have, and that's the next number. And in n factorial, start with n times 1 less than that, times 1 less than that. And hopefully you're starting to see, wait a minute, these are all the same from here on. So everything from n and down until you get to 1 will be the same, those divide out. So n plus 1 is all that's left, and that is your final answer.